Okay, here is the second page. So it says circle all the following that are polynomial functions. So remember, when we determine if something is a polynomial function or not, then the exponent has to be positive and an integer. So that are two things that have to occur in order for it to be a polynomial function. So if we look at our first one, and all the exponents, yes, those are positives and those are integers. So the first one is a polynomial function. The second one, when we take a look at 5y to the negative third, negative 3, that is not a polynomial because that's a negative exponent. Okay, next one, the 5x to the 1/2. That is not a polynomial function because 1/2 is not an integer. And following is a polynomial function. Don't get thrown off by pi, because what is pi? Pi is 3.1415, continue, so that's okay. And then the negative 0.83, that just means that it has a y-intercept of negative 0.34. 0.834. All right, then the following. Let's go ahead and look at the next one. Next one, okay, 123, that's okay. Exponent 65, but then 1 over x. How would we write that? Or what's another way to write it? Well, that is x to the negative 1. So x to the negative 1, that is a negative exponent, so that is not a polynomial. So the only polynomials that we have in this set are the first and the third. Number 2, describe the end behavior of the following functions. So remember, whenever we do end behavior, we want to look at the highest degree and then the leading coefficient. So highest degree is odd, is 7, so that's odd. And negative 2, so odd and negative. Odd and negative, I know it's going to have an end behavior that looks like this. So as x approaches positive infinity, f of x goes to negative infinity. And as x approaches negative infinity, y goes to positive infinity. Next one, highest degree is 6. Leading coefficient is negative 1. So this is even, and this is negative. Even, negative, think about a negative quadratic function. As x goes to positive infinity, f of x goes to negative infinity, and negative infinity as well. Number 3, divide using long division. So we have to set this up. So I have my divisor, x squared minus 2x plus 4 then I have 2x cubed plus 3x squared minus x plus 6. Okay, when doing long division, the very first thing we have to do is divide our first terms. So we have 2x cubed divided by x squared, that would be 2x. So I'm going to line it up over my x term just so I can keep everything nice and neat. After that, we are going to multiply 2x by whatever we're dividing by, the divisor. So 2x times x squared is 2x cubed. 2x times negative 2x is negative 4x squared. 2x times 4x is 8x. Then I'm going to subtract. Whenever we do long division, these first terms should always cancel. Positive 3x minus a negative 4x, that's a positive 7x squared. Negative x minus 8x is negative 9x. Then you're going to bring down your last term. After you've done that, you start the process all over again by dividing your first terms. 7x squared divided by x squared is 7. Then I'm going to multiply. 7 times x squared is 7x squared. 7 times negative 2x is negative 14x. And then 7 times 4 is 28. Then I'm going to subtract. First terms cancel. negative 9x minus a negative 14, so that's a positive 14, so that leaves me with 5x. 6 minus 28 is negative 22. Since there's nothing else to bring down, that is my remainder. So I'm going to write my polynomial, my final answer, as x squared minus 2x plus 4 plus, no, sorry about that, 2x plus 7 plus your remainder over your divisor. And that's our answer. All right, question number 4. Divide using synthetic division. Again, because they give us a factor, we have to set that factor equal to 0, and we get 2. So that is what we are dividing by. So again, every single power has to be accounted for. So 2, 0 for my x cubed, negative 6, 0 for my x term, and 12. Bring down the 2. 2 times 2 is 4. 2 times 4 is 8. 2 times 2 is 4. 2 times 4 is 8. 12 plus 8 is 20. So that would mean that 20 is my divisor. So here's my constant x term, x squared term, x cubed term. It always is going to drop 1 power whenever you do synthetic or long division. So we actually synthetic division. So we have 2x cubed plus 4x squared plus 2x plus 4 plus 20 over my divisor, which is x minus 2. And notice, I know it doesn't ask for this, but remember that x minus 2 is not a factor. It's not a 0. It's not a root because the remainder is not 0. Number 5, write a polynomial in factored form that meets the following requirements. Degree of 5, only zeros of 2 and 6. So there could be multiple different correct answers for this one. So your answers may vary. If it has degree of 5, then we need to think about our multiplicities. So that means we could have a multiplicity of 3 and 2, of 1 and 4. I guess those are our only options. So you decide. So let's see, for my first factor, x minus 2, I'll just give that a multiplicity of 4. My next factor, x minus 6, I'll give that a multiplicity of 1. That's one possible choice outcome that you could have. So your answer might vary for A. It also might vary for B. So degree of 6, only zeros at 7, 9, and 11. So this could have multiple different ones, but just remember when you add up the degree of all of your factors, it has to equal 6. So I'm just going to have 7 be a multiplicity of 1, so that's 1. 9 have a multiplicity of 3, so that's 4 total. And I'll have 11 be a multiplicity of 2. 1, 2, 3, 4, 5, 6. Your answer might be different. Last question on page 2. Write a polynomial in standard form, so that means we're going to multiply it out. That meets the following requirements. Solutions of 1, so that means it has a factor of x minus 1. X plus 5, so that the factor is x plus 5, and 5i. Remember, you have to use the conjugate. So I have 5 plus I, and the conjugate of 5 plus I is x minus 5i. And I talked about that on page number 1. If you watch page number 1, the reason why we do that is because we want those middle terms to cancel so that we are left with a real polynomial. So I'm going to multiply my first two together right here. So when I multiply that together, I have x squared plus 4x minus 5. And then when I multiply my second together, I have x squared plus 5xi minus 5xi minus 25i squared. Remember, I squared equals -1. So I have x squared plus 4x minus 5. And those terms, those middle terms are going to cancel. So I have x squared minus 25i squared. So I squared is -1, so that would make that a positive 25. Okay, now I have to multiply further. So I'm going to multiply my first polynomial by my second polynomial. And when you do that, all right, so when we do that, we have x to the 4th plus 4x cubed plus 20x squared plus 100x minus 125. Okay, don't forget to combine your like terms. We have x to the 4th plus 4x to the 3rd plus 20x squared plus 100x minus 125. Okay, last question. I'm going to extend the page so that I have more room. So it says solutions of 0 with a multiplicity of 2 and 6 minus I. So that means if it has a solution of 0, what does that look like? What does that mean? That means that the factor is just going to be x. So I have x squared, and then 6 minus I. So remember, when we have this, we have it in the form of x minus and x minus. The reason why I wrote 2 is because you have to use the conjugate. So I have 6 minus I, and the conjugate of 6 minus I is 6 plus I. So don't forget you're changing the sign of the I, not the 6. Now we're going to multiply this out. So I have x squared. Actually, I'll simplify it first. X minus 6 plus I, x minus 6 minus I. Now we're going to multiply it all out. So this takes quite some time. So you have to take x and multiply times everything in the second polynomial. Then -6, multiply times everything in the second polynomial, and I. So I'm going to go ahead and do that. So I have x squared minus 6x minus xi. Then I have -6x, positive 36, and positive 6i. Then I have positive xi, -6i, and negative I squared. Let me just take a second, double check to make sure that that's right. Okay, perfect. Okay, now let's look what can cancel. I have a negative xi and a positive xi. I have a positive 6i and a negative 6i. And then don't forget right here, that is going to change to a positive 1. So what do I have? I have x squared times x squared. I have negative 6x, negative 6x. That's negative 12x. 36 plus 1 is 37. And then don't forget, our final step is to distribute the x squared. So I have x to the 4th minus 12x cubed plus 37x squared. Done and done.